So how do we determine the empirical formula? Well, the empirical comes from, the word experiment, and we're going to use some experimental data to figure it out now, the empirical formula. There is a process on how to do it, and so what I'll do now in this video is that I'm going to outline the steps, which will be always successful. These steps will be always successful to getting you guys to the final determination of the final empirical formula. All right, let's go to the example 9.19 on page 363. And so let's read the question here. So this is what's given. The percent by mass composition data for the chlorofluorocarbon of 3 and 12 are as follows. So you got 9.933% of carbon. I'm going to just use carbon. It's abbreviated symbol. 58.63% of chlorine, which is Cl. And I also got 31.44% of fluorine. So what they want me to find, empirical formula now. So the question is empirical formula, question mark. So once you see the percentages here listed, always assume that you have 100 grams of this sample. That will alleviate the pain of converting the percentage into the grams. Once you assume it's 100 grams of the sample, so now all of these percentages of each element become very simple as 9.933 grams of carbon. Now will be also 58.63 grams of chlorine. It will be 31.44 grams of fluorine. And so remember, guys, when we do empirical formula, remember how we done for C6H12O6. All of these numbers, they're nothing else, just the moles of a substance. 6 moles of carbon, 12 moles of hydrogen could be read as 6 moles of oxygen. And so when we found the empirical formula, we pretty much got for a glucose molecule is that 1 mole of carbon to 2 moles of hydrogen to 1 mole of oxygen. So in other words, what you need to convert every time, guys, you do empirical formula, the grams into the moles. And you've done it so many times now, so it should be just second nature for you guys. All right, so let's do this exercise. So this is my molecule here that I'm actually trying to figure it out. CF, let me see. So let me just separate the grams from the percentage so there's no confusion here. So I got C, Cl, and then I got F in here. And so what I'm looking here, I'm looking for these little guys here. Or what I'm looking here, the question mark is nothing else, it's just the moles. That's what I'm looking for. Okay? So let's do the conversions. So first I'm going to convert the carbon into the moles. I'm going to say that one mole of carbon is, of course, 12.01 of carbon. Given desired, again, there's nothing else, just the conversion. I got this 1 mole of carbon from the periodic table. So I'm going to use now my calculator to figure it out, that number. I got 4 significant figures here. 9.933 divided by 12.01. So I got this first data point here, first number of moles of carbon. It's 0.827. Again, 4 significant figures. I'm going to put 0. And I'm going to put the next digit that is not significant. I just like to do it because this is an intermediate result. And I don't want to have a discrepancy in my last uncertain number with the one that the book may have. So that will be now moles of carbon. Okay. So, I'm always there. I just got the moles of my carbon. So I'm always there. All right. So next one is I'm going to convert now 1 mole of chlorine. And chlorine molar mass is 3545, which could be easily found, of course, in the periodic table. And I'm going to do now 58.63 divided by 35.45. And so I got my, again, 4 significant figures, 1.65, a little 3 and a little 9 moles of chlorine. Okay, great. I'm almost there. Times. The next one, I'm going to do the same exercise. I'm going to convert grams of fluorine into the moles. And this one, from my memory, I know it's 19.00 grams of fluorine, molar mass. Canceled. Let's see if my memory is still, I guess, intact. And yes, just confirm fluorine is 19. And so I'm going to get now my moles, which is 31.44 divided by 19. Again, 4 significant figures. That will be 1.654. And I'm going to put a little 7 here, moles of fluorine. Okay. So I'm almost ready. So let me just separate these guys a little further apart. And so what I'm going to do now is going to put Cl, fluorine. So let me just fill the moles in here. So I was able to figure it out that the carbon contained 0.8270, little 6 moles. The chlorine 1.653, little 9. And fluorine is 1.654, little 7. Okay, but remember, guys, we talked about the empirical formula, and so what we stated that it has to be the smallest whole number ratios. Even though I found the moles of each of the element in this particular compound, I still don't have the smallest whole number ratio. So how could I get it? So mathematically, I know that the compound has a fixed composition. And if I take now the smallest moles, in this case, carbon has the smallest moles, and divide all of these by the smallest moles, all of these elements, the number of moles, but the smallest number of moles of whatever element produced the smallest number of moles based on our calculation here, that would be my next step, and hopefully the last step. 82706. And again, but the same number, 82706. All right, let's see what I'm getting here. Okay, so carbon apparently is going to be divided by the same number, so that will be 1. This looks like it's going to be 2, so let me just plug it in. So I got 1.653, little 9, and I'm going to divide it by 0.82706. Yeah, it's 1.9997. I mean, this is pretty obvious. It's a 2, we can round it off to. And the next one is the same as a fluorine, so it will be also 2. And that would be your empirical formula, which is found using this approach here from percentages, assuming we have 100 grams of a sample. So we're making them just the grams instead of percentages, converting to the moles. And then what we do is taking the smallest number of moles, whatever the element we got here. In this case, moles of carbon was the smallest, and we divided each and every element by the smallest number of moles to get our empirical formula. In most of the cases, we will get the empirical formula. In some of the cases, we may get something like CH 1.33, let's say O. And after did all of these steps, you got something like this, and you go like, well, I still don't have smallest whole number ratio here because I got 1.33, and here I got 1, and here I got 1. So what am I doing here? So sometimes you will need an extra step to do, and the way to do it is to find the, start with a 2. You're going to say 2 times 1, of course, 2 carbons. 2 times 1.33 is going to be 2.66. Still not whole number. You cannot really round it off the 1.33 to 1, because it's a little bit too much of the error when you're doing this kind of elemental analysis. So I'm going to do now 3 times 1 will be C3. 3 times 1.33 looks like H4. And 3 times 1, oxygen, it's like I'm doing distributive property in mathematics. So now when we did this step, we actually were able to figure it out now, the proper empirical formula. And so this empirical formula if extra step is needed after you've done all of these steps, you still did not get whole number ratios, you will have to now do the 2, do distributive property in all of the elements to see if you get the whole number ratio. If not, you're going to go 3 increment 4 until you guys get that whole number ratio, and that's how you figured out the empirical formula of a substance.